right, so I am, my name is Tim Estes. I'm not used to speaking with a mic. My mom was an opera singer, and so I never had to learn how to, actually learn how to project from a really young age. So I started this company about 12 years ago, right out of school, about a year and a half before 9/11. And we got our first client working with the Army right before it happened. And it's still, it's mind-blowing to think it's been 11 years. And this clearly became a big priority. You could really say that 9/11 gave us the world's first really, really, really big data problem. And so what we sought to do was to build a capability that would fundamentally transform the problem we had, which is too few analysts to read all the material necessary to connect the dots. There have been many technologies that have worked to connect the dots in the years since then, but the problem was we don't have more attention. And I think that I'll start there, which is with the sort of obligatory big data slide, but I generally talk about two things that I don't think a lot of people talk about enough, which is that we have sort of finite, flat human attention, because we're not adding a lot of people. And the biggest explosion of data is in things that have taken human attention to understand. And so what the gap has been is the automation of that kind of understanding. And I'll drill in very specifically into what that means in terms of automation and actually show you, what it does. But essentially, we crossed that threshold years ago, and now in the business area in the last 24 months, we've seen a huge sea change, especially in the area of email. And so we've seen there's basically a set of applications that have emerged out of this understanding gap. The first and primary one that's emerged is one that essentially was about finding things that were said reputationally or problematically in email, and you see it come up all the times in the news. And so what we've seen essentially is that the risk there has now reached such a threshold, and the automation has reached such a necessity that the financial area became of interest. So in the last year, we took on some capital from the partners at Silver Lake. And previously, we had invested by InQtel, which was the intelligence community's investment arm. And so we kind of made that trick. So if I were going to sort of describe what we're doing in a far more interesting and elegant way, ironically, Scott Adams got ahead of it last week. And when this was sent to me, I actually was floored and realized that new material is going to be necessary. So I guess it's timely, right? And thankfully, it is more than a framework. It is actually a fairly substantial piece of engineering that's taken over 10 years to build. So what is it? We basically have worked fusing the area of natural language processing, purely statistically driven, meaning we can train purely by examples. And we have therefore been able to break through the problem of sort of customizing for rules and computational linguistics by domain over the last couple of years. So in January 2011, we only did English. We do 9 languages today. It takes us about 2 people in 2 to 3 months to get a whole language done in our system, from the language processing all the way through to the resolution of entities. We've never seen anyone that could do that, and we don't say that in any way cockily. We just learned so many lessons along the way, watching other people do great things, because there have been many good companies in this space. But those companies have been limited in the approach they took, such that it required a lot of human engineering and human knowledge investment and services to adapt domain to domain. And that's why we haven't deployed in the enterprise, right? It's because these things work in a silo, and they've never worked as a general algorithm. We've never found the entity version, the entity-centric version of PageRank. And we've worked hard to do that. And that takes 3 big steps. It takes a read step, where you break data and text into features and relationships inside of every message, every document. I'll kind of go through what that means in a minute. And then that's just the beginning. And a lot of people stop there. A lot of people stop with sort of ETL for unstructured data, where they'll process the text and dump it in a database, start counting it and visualizing it, and think we're done. But we end up with actually the wrong counts because we don't resolve the entities. Or we count things together that should be separated because we don't disambiguate the entities. So the big problem was figuring out the truth, and the truth requires resolution. So we spent a lot of effort and energy, and 3 patents, 1 more on the way, to look at how you would learn how to resolve entities without a human in the loop using unsupervised machine learning at scale. And so we are as good as it gets on that problem. And that's been deployed on very large systems and very interesting customers. Not in the banks yet, but that's changing very quickly now. So, so that's sort of the resolve layer is how do you get one big knowledge graph? Google started coining this phrase, the knowledge graph. You've seen it in the corporate press. And as if you actually talk to them and know what they're doing, they have great stuff in the labs, and what they have in production is using schema.org to tag your data so it boosts your rankings. We automate the creation of the knowledge graph from the data, from the raw data, without any human aiding. Doesn't mean you can't use human data or use aliases, other things. That makes the system converge faster, and it also helps it fix mistakes it makes because the math doesn't always add up because people come into communication with context that's not in the signal. That's why there's always going to be a hybrid of supervised and unsupervised to make this problem work. So finally, the reason step is you have this massive knowledge graph of billions and billions of entities and relationships that we created in certain other customers. How would you slice the piece you need to be able to serve an application? And that means you have to rank parts of that graph, cut the right subgraph, hand it back to the application, and do it like a search engine, but over entities and relationships, not over content. And so that's really the reasoning step is the algorithms that make that possible. So we think this actually ends up being the analog to the relational database for unstructured data in a big data context. We think that the relational database was designed with certain assumptions, and some of those assumptions have been relaxed for scale. As people understand how many people here know the CAP theorem? Okay. So a lot of the NoSQL movement has been driven by that idea, right? The idea that essentially if we relax certain components of it, that we can achieve scale by getting locking contention and other types of issues to work in a parallel architecture. And that was the limitation of engineering, and the limitation of semantics in the database. I mean, you had to come up with a knowledge representation that could be slightly contradictory or majorly contradictory, that could be learned and built up, where ontology was not required in advance. Because meaning is invariance and hierarchy. I'm a philosopher by training. So if anybody asks, so that's a philosophy statement. But it actually works in algorithms amazingly now. So getting a little deeper, what do? We take in every single document and we do things you would kind of expect, like how do you statistically figure out where the sentences end? How do you figure out what are the tokens? So what are the individual pieces? That actually is relatively easy. You can do about a 95% solution in English with a few heuristics. In Chinese, it's really, really hard. So we have the only statistical tokenizers that works at scale in production. So how do you figure out what role things are playing? Well, that's great too, but that's really hard in degenerate grammar like Twitter. So once again, statistics will win. Grouping, knowing what to put together is very key, because that's the entities that actually are the subjects of your investigation. And finally, to be able to use extraction where you're actually typing and filtering and saying this is a category of interest. So that's stuff I think other people have done before. We think we do it pretty well or better. But it's just the building blocks, because what you're trying to do is you're trying to go from something like an email and determine what's connected inside of the email. What's co-referent? What's associated? How's it linked, an entity linked in time and space, because that's what defines reasoning, is the change in things in time and space and how it builds up. So structure, change. Where is it? Whole companies have been built off that idea and then sold 3 or 3 times. And so we think all those things are prerequisites to build out like basically a resolved event, and that's the building block of going from text to knowledge on a single document, and then you have to be able to link it all together globally. And so there's a lot of varieties of the way we use words, but ultimately what gives it away is we cannot change the pattern in which it's used without changing the meaning of it. And so if you're going to reverse engineer the pattern of usage, you can cluster and get the meaning of a word and back into what language means at a low level. So we did all that work algorithmically, and then so we're a backend company. We're definitely an enterprise company. We're a backend company. I'm going to show you pretty things in a second, but I need to tell you what went into the pretty things, because that's where all the interesting stuff is at. And so what we do is we support we do all this in Hadoop. We've done some tuning there, but basically use Cloud Ares distribution, have used MapRs and others, so we know most of the distributions and the relative performance trade-offs. And we write out through a layer to 3 different distributed, essentially, data warehouses: Cassandra, HBase, and cloud-based Accumulo, which is something. Who knows who Accumulo is? Or Cloudbase? you need a cookie because that's really good. There are very few that know what that is, but you'll hear a little more about it. But that's the National Security Agency built a secure, basically, big table clone. And they got funded a little while ago. Interesting stuff, some friends wrote that. But it's really some very interesting stuff relative to the ability to scale out a knowledge base that's essentially a graph. Right? It's a connection of entities and relationships. It's not a pure graph like a Neo4j where you can do really sexy traversals. We're working on that one, and we're working with other people. So we try to not play in the infrastructure level. We play essentially as an analytic layer that gives a knowledge representation that's machine usable, and therefore end-user usable through various tools. So we lean heavily on partners like DataStax. We were at one point running the largest Cassandra cluster in the world with one of our clients. And they published a white paper on it, at the DataStax site, it's still there. And so we stress these things, and I want to give kind of a little bit of a plaudits to those companies, because without the infrastructure companies maturing these things, applications like this would require us solving 4 or 5 extremely hard problems instead of just 3. And so that's kind of what we tie to. So what do? We take all that knowledge, we built an API to pull stuff out of it, and then we've actually pulled it into various applications, and I'll show you some of them. So the initial one that we had done some work on was, I have an early version of it, but given the timing, I'll probably keep that. I have one that actually is in use in production in certain countries. But I'm going to say and kind of move forward. This is 9/11, and so I will show you kind of the actual application in motion. It's not too washed out. And so what we did is we basically have worked with certain parties to put in entities against a big bunch of unstructured noisy text. And when I say unstructured, I mean this stuff is like all cap language translation group. So you can appreciate that you're training a language extraction tool. A lot of times the ones on Newswire work well because capitalization as a feature is so strong at giving you a proper name. You get all cap data with a bunch of inline junk, that doesn't work anymore. If you get an export out of an index where it's all lowercase normalized, like an email tool, it's not going to work either, which is one reason why these entity extractors in the past have done so poorly in enterprise data. So what we've done is we basically have built a way to navigate, in this case, tens of thousands of documents, and see the connections of entities and relationships as they are set across it. So you basically search and you see, and you find a fact of interest. So and you can kind of navigate through it. I can let it go and show more. You'll see other entities here on the side where the system will kind of always have an entity layer tied back to whatever the focus of the unstructured content is. So that's the thing that we were brought up on, and that's the piece that's in use. And since FinTech, when we were part of this program, we basically started working in the area of the financial enterprise. And we have a couple relationships that will be announced in the next couple of months. I'll say the press release later. But in one of them, we did some work, particularly around how to take in financial newswire data and start analyzing various companies and see what they interact with in the data. So you have a lot of sim analysis tools out there. How many people are in sim analysis in the room? Is there any? One sim? Any? So a lot of these things are really modifiers. They're how you describe or characterize a given entity. What's interesting, though, is knowing the fact the entity is existing in. What was the subject of it? What was the object of it? And the resolution of those subjects and objects is key to knowing what knowledge is in question. And the sentiment then colors the knowledge. And I think a lot of sentiment you'll encounter, since most of you are probably users or buyers or people dabbling in it, if you're not building it, you'll encounter sentiment where essentially what it is there for is to count various kinds of words, negative or positive, versus being able to sort of stop for a second and say, okay, Netflix and it interacting with things like Amazon, and it interacting with, or Nokia interacting, being unseated by Apple. And so basically turning the unstructured data into structure, but minimizing the human investment to get the structure out of the data unlocks a pretty enormous amount of value. And the ability to resolve the different data allows us to see an accurate picture and then start to dive in. And so in this case, you'll have California-based Apple, and you want to see what is Apple doing. Let's see all the different types of things that's going on. Well, it's acquiring It's got a unseated Nokia. It has something. It has some joined Microsoft and something. It's sued Samsung, accused Samsung, bounced Samsung. So in any case, what we've done is we've seen that the ability to structure the unstructured data in this model allows us to navigate knowledge about 10 to 100 times faster than we have seen before with analysts in the intelligence space, and we're now applying the financial, and we'll see if similar returns are there. So, so I'll kind of, at that point, I'll sort of wrap up here and move into sort of a summary of what we do, which is we have done basically a lot of the work to make people able to use a variety of data sources without basically a massive custom knowledge engineering effort. We did that because the type of data we spent 10 years learning how to understand was data that no one had a pattern for. And when they had a pattern, it made them have bad assumptions about it. Bad assumptions have very big consequences. And so an assumption-free analytic that worked at scale on unstructured data was the necessary deliverable. And now we're repurposing it. So I'll kind of stop there, open up to questions. Happy to field it. I have no idea what the time is on it. But
two questions, if I may. Do you guys use lemmatization?
We generate lemmatization. We don't use it.
Okay.
We generate candidates for that. Roll up, but we don't use lemmatization to roll up. So the predicates will get rolled up together, for instance.
So you're doing centralization of the concept into a single entity that you can then handle all of these variables.
Essentially, yes. I mean, it's a clustering operation, but
okay.
yeah.
And same, I guess along the same lines, not all languages have consistent syntax or even spelling.
Right.
How do you deal with some of the Middle Eastern languages that have 15 different spellings for the same word?
Once again, the nice thing is one thing all languages share is that, and this actually has to do with sort of information theory and channel, source channel theory, is that when you're sending a message between two parties, they have to use the encoding and clues from the encoding to decode it on the other side. Which means that even if they're using a different symbol for it, the context gives it away. So one thing we did early on, and this is in the patent, so you can go look at it, but one thing we did early on is we realized that you could figure out what a word meant, not based on what tends to co-occur with it. That was a somewhat traditional approach. But if you said everything that's ever occurred with it, pulled out the statistically insignificant stuff, you kept the stuff that was statistically significant, and you clustered the vector but not the focus, then basically the error in that fit gives you the meaning of the word. And that works for all languages. Ironically, it worked so well when we moved from English to Chinese, which is our first other language, that we had to change the parameters of the clustering algorithms, which surprised us. So maybe something more interesting in it than we knew. But that was an interesting experiment last March, April of 11. Yeah. So, questions? Go ahead.
I know I'm reaching, but is this open source?
No. It's not classified. So that's an upgrade. So. Good.
It's sort of a higher level question, I guess. Both your company and SmartLang are really kind of advancing the application of linguistics scholarship. And I'm sort of wondering if on the academic side of this, is there this kind of body of knowledge and talent and skill that's been kind of unexploited? I don't mean exploited in a negative way, just unexploited. And suddenly the marketplace is catching up to figuring out how to use all this scholarship, or is there kind of a dearth of scholarship, and you're really advancing the level of that scholarship on the application side?
Do you want to take part of that?
Yeah, I mean,
he's a linguistic background.
I just mentioned earlier that when I was 20 years ago, or 4 years ago when I graduated from college, people were saying, linguistics and computers, they don't understand why it would make sense. And what I was envisioning was something like Siri, and I thought, well, wouldn't that be cool 20 years later? So I think there's a combination. My guess would be that it's your first chart with just the huge growth of unstructured data, of how do you put that together. But there are some really incredible things happening in academia right now at Penn and at MIT and a few other places where they're really focused on linguistics that I think are very, very interesting. I would say that some of the challenges around the degradation of language on Twitter and things like that are going to be significant, and just the explosion of data and how do you analyze it and then find meaning out of it.
Yeah, and I think that one thing is we've really done a lot to blend information theory and linguistics in what we've done, along with machine learning algorithms, particularly unsupervised. So essentially, how do you use the signatures of things based on features and then statistical properties of things to decide that that means something? And it was based on this very high-level idea that the meaning of something is its invariance in use. I was a Wittgenstein guy when I was in college, and so meaning is use is sort of like one of the things you learn in the introductory classes. And so that kind of ends up being the sort of philosophical foundation. But implementing that is really hard. You have to take things that are like, for the geeks in the room, like k-n-squared problems and find a way to linearize them and parallelize them, which was what we did to make this possible with very minimal loss. So that ends up being like, so the implementation ends up being really hard. I think we're advancing the implementation. I don't know that we're really advancing the linguistic side of the science, but maybe one thing we're doing, kind of to go to a higher level point, is we're democratizing a certain kind of utilization of knowledge. Because this used to take linguists to go in, the deep advanced linguists to go into these languages like Farsi, which we did last year. Because we couldn't find an Urdu or Farsi corpus worth anything when it came to like predicates and relationships that was strong enough to train on. So we either had to get linguists in that also knew the computational side and go that approach, which we knew wasn't viable from the scale. We had 3 months to do it and it wasn't possible. Or we had to invent a tool, which we did, to tag the data and basically take native speakers, one of which we found at a restaurant in Nashville, and have them start tagging data.
Just looking for a record deal.
Yeah, well, that's right. That's right. So it's not actually a genre we have enough of in Nashville. So, but yeah, I think that's probably. I think that this opens up a huge door because people need to have skills where they can use their minds and their ideas in a way where technology doesn't get in the way. And when handling unstructured data, it's been so driven by rules and knowledge engineering and us mapping to the machine that we have all these very talented people that spent their college years not learning how to do that. And that doesn't mean they're not talented. It means they just were bored with the frustration of making it work. I mean, I started this company because I thought software was too stupid. And I figured someday all software would learn, and whoever made software learn would build a very valuable company, and it would change the world in very positive ways. So that's what we're trying to do is, make everybody their own Google. And I think there's immense empowerment that happens for people, and it doesn't mean you give me your data, which I like that side of the model too. So, all right, that's good.
Time for one more.
What else? You had one more, I'll give more, but go ahead.
Okay, well, so most of the technology that I showed in your stack isn't really well suited for what you're doing. Did you build your own full text search engine, or are you using something like Lucene?
No, we just indexed it in such a way when we did it first in Cassandra. I mean, we've gone through, we've been doing this for a long time. So we've gone from like Oracle 8i a long time ago to essentially, so we had like a multi-thousand line PLSQL script in the very, very first versions of this, all the way, that's been like 03 and 04, all the way up to, through a Java file system. We did Genie in Reno. You remember Genie? Who knows Genie? Okay. So they had a lot of that nailed long before Hadoop got around. We just didn't have the bandwidth between nodes to make it work. We do now, and so Hadoop came along, and it's really cool. But I agree. I think what we're looking for, actually, just jumping ahead on it, is we think with Yarn and MapReduce 2, there's immense possibility to solve some of these issues, especially in real time. So fully agree with probably where you're leaning toward. And I think as we go for a 4.0 version, I won't hint at what we're going to use yet because it's a little ways off. But we're going to be using a blend of things that solve some of those issues because we're limited right now. Like, we're an incremental technology. We're not really real time, even though we're really fast. And that's because of the spin-up time of Hadoop, the load times, and the pullback out and the load times. It's a very, very fast batch, but still batch. We think you can do a lot better than that. We think Hadoop is getting better, and we think that between the parties out there like a MapR and Cloud and others are going to help do that, but also the open source community is. I mean, there'll be a store mashup with Yarn and other stuff out there before too long. So,
Great. Thank you very much.
Thank you.